Hello students, welcome back. So now we are going to be performing bivariate analysis on two variables, categorical versus categorical. So first thing I'm doing, importing my pandas as PD, also importing some visual libraries over here. Load my CSV file. This is the one that I'm using to perform my data analysis. I just print out 10 sample values just to get a feel of my data. In this case, I have MPG, cylinder, displacement, horsepower, weight, acceleration, and you can see that some of these values like cylinder, you can see that 4, 4, 8. So that seems to me like these are categorical. Likewise, if you scroll down, you can also see model year. Look at these 81, 76, 73. So this seems to be also categorical. Then you have origin. That's also categorical. You see that Europe, Japan, USA, Europe. So these are categorical. You can also look at the descriptive stats. So that also gives you some idea of what your data looks like. So this is my descriptive stats right here. All right, then coming down. So now let's focus on categorical column. So first thing you want to do is identify your categorical column. So the one way you can identify your categorical column is by looking at number of unique values for each column. So by typing this command print df.unique, that's going to give you the number of unique for each column. So in this case, MPG has 129 unique values, cylinder has 5, and displacement has 82, and same thing with the rest of them. Based on these numbers, you can see that your cylinder, there are only 5 values in cylinder. So that tells me cylinder is categorical. Also, look at this model here, 13 values. So that tells me this is also categorical, and origin has 3. So I would say these three ones are they are good candidate for categorical. So I would use them as categorical. You can also see what the values are inside these cylinders. So for instance, cylinder column, the unique values are 8, 4, 6, 3, 5. These are number of cylinders. For model year, your unique values are 70, 71, 72, 73, all the way to 82. And for origin, these are unique values, USA, Japan, and Europe. Okay, so my categorical column is going to be origin, cylinder, model year, and name. You know what? I really don't need name, so I'm going to remove the name. That's irrelevant. All right. So let's do cross tabulation first. This gives me the count. So let's start with origin versus cylinder. I want to know how many cylinders cars are there for each one of the origins. So in this case, you do pd.crosstab, supply your origin right here, also give your column cylinders right here. Print out your crosstab, and this tells me this prints out the data right here. So what this shows is that how many cars of each cylinder count come from each origin. For example, let's take a look at this number 63. So it tells me for the Europe, four-cylinder cars, there are 63. So 63 cars, they come from Europe that actually are four-cylinder. What about this zero? Well, that tells me that from USA, there are no cars that has five-cylinder. That's what it means. Okay, likewise, you can also do origin versus model year. Cross tab, you supply your origin column, supply your model year, and then print out your cross tab. So this gives me the data right here. So let's look at one of these data. Let's look at this right here. So this tells me in year 1974, Japan has 6 cars. Okay, and let's look at this 29. It tells me for you in year 73, USA has 29 cars. So that's the record. That's what this record displays. What about cylinder versus model year? So in this case, again, you do the cross tab, supply your cylinder column, supply your model year, and that's going to give you this data right here. I think this should be now easy to understand. This one tells me 11. It tells me that for year 1973, for year 73, the number of cylinders, that the number of cars with cylinder 4 is 11. This one right here, 0, it tells me that for year 72, for model year 72, the number of cars with cylinder 5 is 0. Okay, I hope this helps. And now we can also do cross tabulation on proportion. Basically, what it does, it actually calculates the percentage. So I'm just using the same functionality, pd.crosstab, supply your origin, supply your cylinder, except this time now you're saying normalize equal to index. So this way it's going to give you the proportion. And then you multiply by 100, that's going to convert that into percentage. So in this case, it gives me this percentage right here. So let's look at one of these values, 28 right here. This one tells me that 28% or 29, approximately 29% of your cars that are coming from USA that are actually are four-cylinder. That's what this number tells me. Let's look at origin versus model year. Cross tab, same thing. Everything is same except now I'm saying normalize equal to index, and this tells me the percentage right here. So let's look at one of these values. Let's look at this one right here. This is telling me that From Japan, there are 6.3% cars that have model year 72. All right. Then let's look at cylinder versus model year. Same thing. I'm supplying my cylinder, supplying model year, and I'm also supplying my normalize. I'm saying normalize equal to index. That's going to give you the proportion. Multiply by 100, that converts into percentage. Let's look at one of these numbers. Let's say this number right here. This one tells me that for model year 73, the 5.3% of the cars were four cylinder. That's what it tells you. And now let's look at the stacked bar chart for proportions. So first thing I'm doing, I'm getting my cross tab for origin versus cylinder right here. I'm printing out the percentage. And after I print out the percentage, I also want to do some type of plot. I want to see how exactly my, if I can somehow plot my those raw numbers. So this particular graph, ctprop.plot, is going to plot a bar plot for over here. So after I plot this bar plot, so it actually prints out this raw data right here, raw numbers, and then it prints out my stacked bar plot. So in this case, you can see that. Let me just decrease the size of the screen a little bit. All right, there you go. So in this particular instance, you can see that for European cars, you don't have any three-cylinder for European cars. There is no, actually, you know what? Let's start with European. So European car have no three-cylinder cars, and they have no eight-cylinder car. They only have four-cylinder and five-cylinder and six-cylinder, because you can see that four, five, six. These are only the finite numbers for European car. This is my European car right here. Let's look at the data right here. So you can see the European car has 4, 5, 6. If you look at these colors, they only match with 4, 5, and 6. That's it. And majority of the cars are four-cylinder right here. And you can see that from the data for European cars, 90% of your car are four-cylinder. Likewise, you can read the same information for the rest of them, the rest of the other countries. So observation, let me just increase the size. So this is just a small observation. You can actually draw more conclusion, but I'm just giving you a little taste of this. So for Europe, major proportion of the cars are four-cylinder. We saw that. We can see that from here. This is your four-cylinder right here. European car has 4, 5, 6 cylinders. Showed you that. Only US has 8-cylinder car. Well, you can actually verify that. You can just come over here, USA. You can see that 8-cylinder is right here. And you see that 0, 0, and only 41.6. So for 8-cylinder, your Europe is 0, Japan is 0, only US has a finite number. And also you can see that from the colors over here. There are 8-cylinder right here for US, but no, that you would not find that color for Europe and Japan. All right. So likewise, you can draw other conclusion from this. By the way, you can do the same for origin versus model year, cylinder versus model year, and it's a good practice that you try to do these things. Another tool that's available in your arsenal is Seaborn's count plot. So in this instance, I'm actually plotting a count plot between origin versus cylinder. These are my two categorical columns. So call your Seaborn count plot, supply your data frame, your x equal to origin and your u equal to cylinder. And in this case, I'm choosing my palette to be set to. When I plot this, let me decrease the size of the screen. So when I plot this, it gives me origin versus cylinder count plot. So a few observation, if you look over here, your only US has 8 cylinders. So if you look at the 8-cylinder color, it's like a light green right here. And you don't find that anywhere else except in US. That's it. This is your US, and US has the light green. They don't have light green over here. So you can draw these types of conclusion from here. Let's see, and then also only Japan has 3 cylinders. So if you come over here, your 3 cylinder is dark green, and you can see that only Japan has this dark green. You don't see dark green over here. You don't see dark green. Only Japan has that. So only Japan has 3-cylinder. And likewise, you can draw other conclusions from here.